Good morning everybody. Today my topic is types of semiconductors. Semiconductor materials are normally small band gap insulators. These are materials with electrical properties in between conductors and insulators. Silicon, germanium are pure semiconductors. Gallium arsenide is a compound semiconductor. It is commonly used to make LEDs. The beauty of semiconductor material is that its electrical properties can be controlled by using doping. Now, types of semiconductor materials. Semiconductor materials are found in elemental as well as compound form. In elemental form, we have silicon and germanium, compound gallium arsenide and its alloys. Semiconductors can allow or suppress electric current flow. They have an electrical conductivity value in between values of conductors and the insulators. That is why we call them as semiconductors. Conductors usually have free electrons in their outermost shell. These electrons can conduct electricity. Examples: copper, silver, gold, aluminium, nickel. Among them, silver is the best conductor. In insulators, no free electrons are available for the flow of current. Examples: glass, ceramic, plastic and wood. In semiconductors, there are 4 electrons in their outermost shell, and we know that examples of semiconductors are silicon, germanium, gallium arsenide, and these 4 electrons are not free to conduct electricity. Pure semiconductors belong to carbon family, that is, they are group 14 elements. The silicon and germanium are pure semiconductors. In cluster formation of semiconductors, atoms link together with one another by sharing their outermost electrons. These links are called covalent bonds. If the material is pure or intrinsic semiconductor material like silicon, the crystal lattice structure forms an excellent insulator. Since all atoms are bound to one another, no electron is free to move for the current flow. To improve their properties, we add impurities, that is called doping. Doping to improve the electrical properties of pure semiconductor materials, some impurities of neighboring groups, that is group 13 and 15, must be added to pure semiconductor. These impurities are called dopants. The process of controlling the electrical properties of semiconductor materials by adding some impurity atoms is called doping. Now, types of impure semiconductors. Impure semiconductors are also called extrinsic semiconductors. There are of 2 types, N-type and P-type semiconductors. The semiconductor material doped with atoms of an extra electron, that is group 15, is called N-type semiconductor, where N is for negative, which is the charge of an electron. The majority charge carriers are electrons. The donor dopants are phosphorus, arsenic, antimony, bismuth. Semiconductors doped with elements of 13 group produce vacancy in the crystal of the doped semiconductors. Such semiconductors are termed as P-type. The letter P stands for positive, which is charge of the hole. The majority charge carriers are holes. The acceptor dopants are beryllium, aluminium, gallium, indium. Boron, aluminium, gallium, indium. Now we study about semiconductor devices and their applications. The main application of diode is p-n junction diode. p-n junction diode is the most basic electronic device made from extrinsic semiconductor. It can be created by bringing together a p-type and n-type region with the same semiconductor lattice. It is used as rectifier, LED, solar cell. During p-n junction, then formation of p-n junction, majority carriers from p side and that is electrons from n side diffuse across the junction, and around both sides of the junction a layer is formed that is called depletion layer. The main function of this, the diode is depends upon this depletion region. Inventors. p-n junction diode was invented by Shockley in 1947. His team, that is in collaboration with his co-workers, they got Nobel Prize in 1956 for the invention of transistor. It is a logical extension of p-n junction diode. Now forward and reverse biasing of the diode. The diode is said to be forward biased when p side of the diode is connected to the positive terminal of the battery and n side of the diode is connected to the negative terminal of the battery. During reverse bias, p side of the diode is connected to the negative terminal of the battery and n side is connected to positive terminal of the battery. During forward biasing, majority carriers cross the junction, move across the junction and they conduct a current. During this process, resistance of the diode becomes low, and it also works as a switch rectifier. Students use rectifiers. In rectifier plus 2 ਦੇ ਵਿੱਚ ਟੌਪਿਕ ਹੈਗਾ, ਇਹਨੂੰ ਤੁਸੀਂ ਅਲੱਗ ਵੀ ਪੜ੍ਹਦੇ ਹੋ, ਜਿਹੜਾ ਕਿ AC ਨੂੰ DC ਦੇ ਵਿੱਚ ਕਨਵਰਟ ਕਰਤਾ, ਤੇ ਐਜ ਏ ਸਵਿਚ ਵੀ ਡਾਇਓਡ ਡਿਊਰਿੰਗ ਬਾਈਸਿੰਗ ਹੀ ਕਰਦਾ ਹੈਗਾ। ਤੇ ਰਿਵਰਸ ਬਾਈਸ 'ਚ ਇਹ ਕੰਡਕਟ ਬਿਲਕੁਲ ਨਹੀਂ ਕਰਦਾ ਕਿਉਂਕਿ ਇਹਦਾ ਰਜਿਸਟੈਂਸ ਬਹੁਤ ਜ਼ਿਆਦਾ ਵੱਧ ਜਾਂਦਾ। हाँ डिप्रेशन कर दो डायोड दे दियां हुन। नाउ वी स्टडी अबाउट एप्लीकेशंस ऑफ डायोड्स। डायोड्स आर यूज्ड एज LED, digital display, transistor, amplifiers, oscillator, inverters, Zener diodes which is also used as for voltage regulator, battery eliminator, mobile laptop charger, logic gates, flip-flops, photodiode, solar cells. Now we reach at the conclusion. The advancement of modern technology is due to semiconductor devices based gadgets such as cell phones, computers, cameras, satellite communication, storage, LED, solar cell. Now think about semiconductor. If we have no semiconductor, then there will be no mobile phones, no computer, laptop, printers, no satellite communication, no multimedia projectors. Then it will paralyze our daily life. Thus, semiconductor materials can be called as the backbone of the modern technology. Thank you.
पीछे आके पढ़ाओ पढ़